Good morning, dear student. Today we will teach about what is load line of a transistor. Here we can see that a characteristic curve of NPN transistor is shown. Here the axis along to y axis is taken as current passing through collector IC in milliamp. On the other hand, on x axis we have taken VC voltage corresponding to this point and here. Now, what is the mean of the load line? The load line of a transistor is a any straight line which show operating value of current and voltage for a transistor in optimum condition. Here we can see that from here we call point A and here we call this point B. This is a straight line. This is called load line of a transistor. Here it is taken for this transistor, which is NPN transistor. Now we would like to explain what is importance of load line and how can we find and determine for a transistor. By applying Kirchhoff voltage law at this junction, here the voltage at this point taken as VBB. Generally it taken as in some example VCC. Then VBB voltage is applied at here. Some voltage drop at here, some voltage drop at here, and some voltage drop at here. The sum of this voltage and this will equal to VCC or here VBB. The current passing through collector we call IC and the current comes from base we call IB and the current passing through ammeter we called IE. The current IC always equal to IE because the IB is negligible or maybe in microamp and here IC and IE is order of milliamp. So generally we ignore this term when we add the value of current IC. Now by applying this Kirchhoff law, what will we find? Applying the Kirchhoff law at here, what will have the total voltage. Look at this equations. VBB equal to the voltage across this junction equal to current into resistance. The current is IC and resistance is RC. Then the term IC RC plus VC. The VC is the voltage developed between collector and ammeter. This is here we call just VCE and the current passing through IE and RE is equal to IERE. As we know that IC is order of IE, so this equation can be written at the value of IC VBB upon RC plus RE VCE upon RC plus RE. Now we will find out the graph between current passing through collector and the voltage applied at collector and ammeter VC. Then what we will find out? We can see that when the maximum value of IC means that whenever the voltage Vc tends to 0, means that there is no any voltage dropped at here, all the voltage dropped at this point. So in this case, this is VBB upon RC plus RE, the maximum value of collector current, and the minimum value of IC. To find out the minimum value of IC at the point where VC equals to VBB. When VC equal to VBB, then these terms will cancel out and IC equal to maximum in this condition. Sorry, IC is minimum at this condition. Then the minimum value of IC equal to 0 and maximum value of IC equal to VBB upon RC plus R. This is the critical limit between the IC maximum equal to VBB upon RC plus RE and the minimum value of IC minimum equals to 0. To operate any transistor which may be PNP or may be NPN in like such a manner, then the collector current must be lie between this minimum value and this maximum value. The line which is passing through this point is called load line of that transistor. It may vary with respect to RC and RE and beta parameter of a transistor. Whenever a transistor used in a circuit, then there should be taken into account that where load line exists. We must select the value of RC and RE such a way that the operating point must lie between this value of current or this value of current, and we can say that the operating point must be on load line and with a limitations that operating point never to be taken too far from, or we can say the close to VC axis, and never to select VC, RC and R in such a manner that operating point can shift to IC axis. So for best optimum result, we select operating point between these two axes and such like that it can stay at middle of the line, because some parameter will whenever disturb the value of beta, then operating point will also move to left or right side. So whenever we used at here in this point, then it may vary or may shift to right shift or may in left shift, then there will be no changes in result. But whenever this operating point at most right side this line, then in these conditions, when this parameter beta with temperature and changes, then this point also may vary to left and right. Here the left is safe zone, there is no affected of temperature, but whenever it shift to right side, then it will disturb our result. So operating point always try to find in such a manner that it can stay at the middle of load line. So load line play a important role to play to make a circuit which is unaffected and must be like as a manner which we wanted. Thank you.